everyone. I'm Thiyagarajan from AML department. Today I'm presenting my project work to titled Intelligent Examination Submission Framework. Um, let's move into the introduction. Um, Learning management systems such as Moodle are widely used in education. However, many institutions still conduct physical examination, which creates difficult when converting answer sheets into digital submission. The current process involves manual scanning, naming, and uploading, which is time-consuming and error-prone. Um, Problem statement. The main problem identified are manual handling of answer script, incorrect student mapping, lack of verification, and security risk during bulk uploads. These issues reduce efficiency and affect grading accuracy. Purpose of this project. The purpose of the project is to create secure and automated framework that allows scanned answers it to be validated, verified by students, and submitting directly into Moodle. A proposed methodology. Uh, in the upload pass, staff upload scanned answer sheet using a predefined naming convention. System validate file format and metadata, generates integrity hashes and store the file securely. This ensures only valid and untempered answer sheet move to the next stage. And also for student verification, the students log in using Moodle credentials and they can view only their mapped answer sheet. After verification, student initiate the final submission and the system securely uploads the script into Moodle using APIs. The expected results are include a reduced staff overloaded, elimination of upload errors, improved security, and increased transparency in examination submission. The functional and non-functional requirements are the system support role-based access, secure authentication, audit logs, high reliability, scalability, and good performance for large-scale exams. These are the papers um, we are considered for the literature review and we are taken from for the reference. Um, these are the functional and non-functional. And we also follow the SDG goal alignment. This project aligned with SDG 4 quality education, SDG 9 industry and innovation, and SDG 16 strong institution. And these are the project plans that we have allocated for each team members. The tasks are given in the date wise, and we have completed up to the date and we are further proceeding. Um, for the conclusion, to conclude, intelligent examination submission framework effectively bridges physical examination with digital LMS platforms, ensuring secure, accurate, and verifiable exam submission. Thank you. GitHub of our project that is used for syncing all the files, and we have to do the um, real-time model for a framework that integrate various files for backend, front-end, and the middleware framework to make it possible to work in real time. Let's move into the architecture overview of this design. Ensure automation, integrity, verification, secure, and submission of scanned answers sheet. High-level architecture that we have used in this GitHub, we can see that interaction layer, application and backend layer, data integrity layer, LMS or automation layer, user interaction layer, staff interface used to for bulk uploading answers, scanned papers. Staff do not interact with Moodle directly, which avoids indirect submission. Student interface, students log in using modal authentication and can view only their mapped answer set. This ensures data isolation and privacy for users. And in the application and the backend layer, we have used the REST API endpoint for upload validation, review, and submission, business logic for workflow, state transition, access control, and request validation. Fast API is used because it supports asynchronous processing, automatic API documentation, and high performance. performing the processing pipeline inside backend. Within the backend, each answer is processed through the processing pipelines. File uh, file name, pausing model, extract register number and subject code from the upload file name. Validation module ensures the file type, naming, format, and metadata. Integrity module generate a SHA 256 has for each file to detect temporary. Workflow manager assigns states such as uploaded, pending verification, and submitted. These are the pipelines, and the data and storage layer. We can see that the data is implemented using postgrad SQL examination or artifact store file metadata has overflow state and LMS mapping, subject mapping or links subject codes to module codes and assignment IDs. Submission queue temporarily store submission when module is unavailable. Audit log records every upload, view, and submission event. This design ensures traceability, consistency, and fault tolerance. LMS integration layer, we can see that they ensure token-based authentication, uploading files to Moodle draft storage, finalizing submission to the correct assignment, handling API failure using routines and queues. By isolating LMS communication into a separate layer, this system remains modular and maintainable. Here we can see the quick start of the project that we have given with the GitHub commands, and we have to run this command, and we can open our project for initialization and real-time use case. The security and reliability of our architecture is a role-based access for staff and students, encryption using tokens and Moodle sessions, uh, audit logs for accountability, asynchronous processing, submission queues, and retry mechanism for LMS downtime that are more reliable for our improved project. And we can see every API endpoint authentication, upload, and student admin. Each one we have a separate module, and we done with end-to-end real-time project. Um, and with the conclusion, we can say that this architecture provides secure, modular, and scalable middleware solution that effectively bridges physical exams and digital LMS platform, ensuring accuracy, transparency, and reliability. Thank you.